Okay, good morning, and thank you, Professor Eric Tsui, for the wonderful introduction. And thanks for introducing and inviting me to Hamburg as well. I thought I'd make use of this short presentation to say a few words about cloud computing, with especially emphasis on innovation and learning, because I think this is a topic which largely under-addressed. When people talk about cloud computing, they seem to be talking about automation and disaster recovery and that sort of things. The other objective I want to achieve is, I try to articulate whenever I can with some of the other speakers, prior knowledge that's been shared, and if possible, shed more light into inspiring everyone, including myself, to think more how we can do, more Science 2.0 and introduce this in various aspects of the context. Now, of course, the basic modus operandi underpinning this is our transformation, like it or not, into a knowledge economy, right? As in a knowledge society, knowledge economy, knowledge work is prevalent. We are no longer being able to collate our work in a linear fashion. They come in any order, unpredictable, come in small tasks, collaborative tasks. We not only have to use our own, experience, knowledge to solve problems, but we often have to leverage and build upon our networks, collective wisdom, harnessing the wisdom in the crowd and also in our network in order to solve problems. However, the knowledge economy and knowledge work also brings to us challenges, a lot of challenges. And one of the things which, like it or not, that spawns, I suppose, Science 2.0, and many of the concepts in this conference, it's about the interactiveness, the live interactiveness of the Web 2.0 tools and trends. And through the use of this kind of software, usually social software, but not always, a massive number of data and connections are being built up, in a very rapid way. Not my research, but you can surely Google it, and you can find it instantly. I guarantee you, in the first page, if not, even more drastic. It's alarming statistics, if not disturbing. 60 seconds, more than 100 LinkedIn new profile has been created. 60 seconds, 669 million emails has been sent. In 60 seconds, more than 690 YouTube videos have been uploaded. So with this sort of volume and rapid buildup of data, it is impossible for us to, not only just ourselves or even as a group, to stay ahead of everything and be able to sift through all that information. We surely need collaborative efforts. We need intelligence, and later on I'll talk about human-machine cooperative problem solving in order to combat some of these problems and more. And of course, I'm looking forward to the next professor's talk on big data. As far as I know, big data, it's we have to, unlearn something in big data as well. We have to forego exactness and have to deal with rapid decision-making with approximations. So, that was the Web 2.0, and I have to say that for those Web 2.0 software and websites that are successful, they must have garnered a huge amount of, massive participation, and they got to be, running in the cloud, because otherwise you cannot fulfill that sort of acute sudden demand on resources. Now, I don't want to turn this, and I will not turn this into a cloud computing presentation, other than just to point out, for most people, we'll think about the cloud as some kind of back-end resources with scalable, a pool of resources, hardware and software, and more importantly, these resources can be scaled up to support any sort of services in a very easy and very rapid way. The other benefits with the cloud is that, in fact, we can shift the payment options from ongoing payment or prepayment to a post-pay mode, which obviously generate a lot of benefits for small to medium-sized enterprises. So here are some of the characteristics in the cloud: flexibility, on-demand self-services. It's surely running in a web system, supports agility, and provide media services. Not sure whether you heard about this classic example. It's been cited many times in textbooks and also in conferences. Animoto. It's nothing Japanese. Oh, by the way, the introduction of calling people to come back using the gong is very Chinese. And I've been in Australia and Hong Kong for almost entire life. I've never encountered that way of asking people to come back to the room using the gong. Okay. Anyway, so do more and you become more Asianized. Animoto has nothing to do with Japan. It's two whiz kids in America, startup. Very small enterprise, very, very small. They don't have funds, but they have a wonderful idea, which is they allow you to upload photos, and they use artificial intelligence algorithm to analyze what's in those photos, sequence them, collate them, and phase in appropriate music, and then with the appropriate, phase in and phase out. So it's wonderful. You submit photos, you get a video back. Right? Now, being a very small firm, it's impossible for them to, hire marketing experts or to have a big marketing budget. So they turn to, in this case, a cloud. Exactly, it's Amazon's EC2. And they run a competition for 72 hours. In 72 hours, whoever would upload the photos and come up with the best video being rated by people, we get an award. And so they did. Wow, if you look at that, in 72 hours, the capacity demand on the servers escalated to 150 times. None of the world's best capacity planner will be able to plan for that. So in this case, Animoto got away with a great big success, not only with the publicity, not only with the success of the campaign, but also adopting a post-pay model. Imagine if the campaign is not successful, only draw in a small number of people, they only have to pay whatever that's being used. So there are, common usages of cloud applications, which I'm not going to talk about because that's what most people, including IT people, are focusing on. I'd like to turn to services, and I believe the cloud, in many ways that I'm looking at, increasingly serve as a canvas to support service innovation. Some of the concepts have been talked about in yesterday's by other speakers, like co-creation of value. It's much, much easier to connect with consumers, customers, in order to collaboratively develop something or to co-solve a particular problem. Cloud obviously provides a dynamic capability to a lot of firms, and that dynamic capability is not just limited to IT, as you will see later. It also covers human resources and other types of competencies as well. Cloud is about invention, trying out, and even dismantling business models. So once again, it's a great canvas for the discovery, alignment of industry partners and other collaborators inside the cloud, and be able to achieve the right blend of leveraging, enabling, also disruptive technologies. Customer experience underpins the ultimate success or measurement of service innovations. In the previous era, we tend to focus very much on customer satisfaction, but in service innovation, inside the cloud in particular, we focus on the design and the enjoyment of customer experience by our customers. All right, so this is one of the key slides that I want to talk about. In fact, it's the next one. Many people consider the cloud connects computers, data, and a massive scale. And that is surely true. But what's missing there, allow me to enlighten it a bit more, is I believe the cloud connects computers, data, and people at a massive scale. Now, adding the elements of people, in other words, with humans, and humans also have their own people networks, that makes a lot of differences. To say more about this, let's think more about what sort of connections inside the cloud. And I would say that there are three fundamental types of connections. The first one, as you can see here, is the cabling. So these are the hardware network connections inside the cloud. The second type of connections is what I call the people-to-machine connections, right? Because a cloud is not a successful cloud, or none of the clouds is successful if it does not garner or attract a huge number of software to be installed, and a lot of people sign up to use this software. So any sort of social networking software that you can think of, successful, popular ones, they must be in the cloud. People start an account in there. So by doing that, there's already a linkage between the person, you, individual, a human, with the software inside the cloud. The third type of connection is people-to-people connections, and these are the trusted networks, the followers, the fans that you have built up in each and every one of your accounts. So these are people networks. So once again, three types of connections in the cloud. Now, if you subscribe to what I've just said, then you can see the cloud, it's a different mass, put it this way. So we have the hardware, the cabling, the computers in the cloud, CPU, networking resources, and so forth. We also have people in the cloud, right? Or people that are accessible from the cloud, right? Or by the cloud. And these people also develop networks among themselves. The cloud obviously is being used to store a lot of files, data, and software being, installed and operating on them as well. So you can generate using warehousing, data warehousing, and business intelligence software, all sorts of reports, whatever they are, inside the cloud as well. So together, I call this collective mass the knowledge cloud, right? If you frame that as a knowledge cloud, we see something different. Firstly, in terms of the connections, it's been predicted by researchers by 2020, which is not far away, another 4 years, there will be something like 70 billion connections. Those three types of connections, I would say conservatively, today, 2015, there are already at least 12 to 13 or maybe more billion connections there. Of course, to be honest, not all those connections are reachable. Many of them are protected or private. Gartner Group also boldly predict by 2016, which is just around the corner, 2 years and half a year, a third of our digital content, each and every one of us, will be stored in the cloud. So it is really an awful amount of information that we can make use of and accessible inside the cloud. I'd like to, articulate with Professor Bergelmann's talk yesterday. He talked about proposing a European research cloud, and one of the things that he talked about is this data layer, and also the services layer, and also the governance layer. And I remember he uses the word harmonize the data, harmonize the services, and harmonize the governance. So coming back to the concept that I just talked about, the knowledge cloud, I see the cloud as a critical mass, as an intelligent engine operating in the world. So if you combine, what we already know, that as long as the hardware and the cabling and the networking stuff inside the cloud with the people, then I consider, we are dealing with an intelligent knowledge center with massive data and problem-solving skills. And these skills are best represented, manifest by a combination of processes, software, and human intelligence. And of course, being a cloud concept, these are scalable. So in other words, you can, ideally speaking, we can approach and select individual groups of people, discover them, approach them, seek their advice, or offer a space for them to collaborate and be able to solve problems, obviously, on many occasions, with incentives. So in that regard, the cloud is disruptive, extremely disruptive. Now, that's not entirely new. We can learn it from animal patterns as well. Murmuration is a pattern where birds, they fly in holding patterns, and they do that, I suppose, on the left photo, to deter prey, right? And in a similar vein, a swarm of goose are swimming in a cluster way to protect themselves, and also to make them feel warmer, I suppose. So, can we also mimic this kind of intelligence using the cloud? And I think we can, and researchers are already making a head start into this area. So with this intelligent cloud from problem solving, I see there are 3 paths that we can explore, and they are, not mutually exclusive. First one, if there are problems that we farm it out to the cloud, some of these problems naturally are, inclined or dedicated, more suitable for humans only to solve, and we have to deal with massive numbers. But that's fine, because a cloud success is its ability to reach out to a massive number of people. Second type of connections, or second type of solving problem, is computational problem. Maybe it is a problem that requires a huge array of computers, with special software to crunch these numbers, like weather forecasting. Fine, in the cloud we can set up clusters to do this, and we can farm out those problems to those dedicated farm of computers. Then there's a third way, of course, which I thought is extremely enlightening, is to combine the two dynamically to achieve human cooperative problem solving, which partially some of the problems go to machines, partially some of the problems go to humans, and then combine the solution together. So a cartoonistic way of enacting what I've just said, if we have problems that we can farm up to the cloud, whatever that problem is, we have logic in the cloud to decompose a problem into various subcomponents to identify whether any of these components are better for humans, for machines, or a combination of human and machines to solve in order to proceed to the next level. Researcher John Fisher has defined this definition for cloud logic in the cloud environment, which I'm not going to read, and I'm going to leave you with information that you can find out more about cloud intelligence. For those of you who can't wait to put your hands on it, there are commercial software around, IFTTT, if this, then that. It's a simple business rule system that you can set up and in your, in your own discretion in the public cloud, and you can, set that, look, if Berlin's weather or Hamburg's weather is going below 2 degrees centigrade, then send me an email or send me an SMS, right? So these are personal knowledge management tactics that you can apply using some personal business rules in the cloud. More examples. Do you really need more? Well, yesterday Professor Rockwell also talked about pseudo online, as well as this transcribe Bethlehem project, which is obviously one of them, one of the ways of asking humans to solve problems in the cloud. The concept is not new, harnessing wisdom of the cloud. For those of you who like astronomy, you may have come across Galaxy Zoo before. So it's a website that asks people to look at photos and contribute. So 5 photos. And ask you whether you see a Milky Way, in other words, a spiral around the star system, and if there's a spiral, is it what direction is it spinning? So here we go. Top left, there's a spiral, difficult to tell the direction. Top middle, there's a spiral, clearly it's counterclockwise. And top right, there are 2 spirals, interlocking ones, but it's difficult to tell the dominating direction. Bottom left, there's a spiral, clearly it's spinning clockwise. And bottom right, there is no, the Milky Way to talk about at all. So stop there. How long have we used, using our human eyes to interpret those 5 photos? Less than 20 seconds. That's a wow, These are exactly the problem in the cloud that we farm it up to humans to do, because human has got millions of them. And of course, that doesn't mean that always the answer come back is true. We have to work out some kind of mechanism to work out the trust and the authenticity of the result. Americans ahead again. Amazon's Mechanical Turk, still a research and beta project. For those of you who are unaware, go and sign up an account, and you can declare tasks and ask the cloud or people in the cloud to solve it for you. And you have to provide some incentives. You can define the period that you want to start your project to be tackled by other people, and also when you want it to finish. And a snapshot of some of the tasks that is available on a particular day, you can see that half of those tasks available, they are classification. Obviously, humans is better than machines, I suppose, because we've got the context. And the second last one, checking up people's record. That sounds like something that's been put up by private investigators or human or the police department. And the last one is, is this person a musician? And that's, to me, is another wow, because even the might of Google, it cannot give you a yes-no answer. So human decision or human opinion is needed to carry out those investigations. You may have come across this software we call Recaptcha, right, or Recaptcha. Where do you see it? Well, that's on a website which asks you to authenticate that you are indeed a human and not a spider. You know what I mean? A computer spider that is crawling over a website. They usually give you 2 words. Do you know that one of those words, the computer already know the answer, the exact answer? Which means, do you know that one of the 2 words, the computer doesn't know the real answer, right? So Recaptcha, it's a result of a Carnegie Mellon PhD project. So that company is being set up to do machine translation, digitalization. Whenever it encounters a word that it cannot understand because it's too rough, too blurred, whatever, it will use Recaptcha and send it over to thousands, tens of thousands of websites, and ask people when they are authenticating to provide those keywords, all right? And they've set a threshold, so maybe about 20 of the human's answer matches, then bingo, it will feed it back to the machine translation or machine recognition software and continue and take that word to be whatever the blurry scribble. So, and they have publicly declared, thank you to the world. It's been saving them $1 million a day. All right, a little bit about our own work. It's a taxonomy system. Everyone knows about the taxonomy, which is in a way of classifying material. We can apply that to a shared drive. We can apply that to a file system. We can apply that to a website. We can apply it to a document management system as well. Taxonomy rarely changes. Of course, organizations have a responsibility to look after and update them, but in the real world, it rarely changes, and it's top down. Coupling with a taxonomy system makes a lot of sense if we can combine it, because taxonomy, it's gathering of text at the user level, right? In Flickr, in YouTube, in many of those social network websites, people provide labels and you gather them, you analyze them. So combining the two, in one of our projects, we were able to find, the middle of road approach that come up with a hybrid navigation mechanism. And that makes a lot of sense because on the one hand, there's a top-down governance about the general structure, but on the other hand, there's also sufficient and rapidly refreshed tags that's provided by people, that can help to navigate. A number of hurdles needs to be overcome, which I'm not going to go into details. In this case, it's an English system where we have to handle a lot of syntaxes and syntactic incorrectness, recover from incorrect keywords, and also merging of stems and variants of words, identify whether these words are authentic or not, but you cannot throw out the word, for example, is iPhone is not in a dictionary, but you still have to recover it and use it, and then that's by checking WordNet and other things. So what sort of applications we can do to it? Now, this is a poster by the Hong Kong railway system. It's a very nice example of illustrating how we can apply to it. In this case, you can see that there's a route map, of the train system on the left-hand side. On the right-hand side, even though that is not in German or in English, but you can kind of see there's photos of some tourist attraction places. But this whole thing is static. It's a poster that is being put out by the marketing department of the railway company. So what our system actually does or can do is to refresh the tourist attraction part by citizens' contributions, right? And that's a Science 2.0 concept. We have applied the software, developed a prototype, and applied it to several sites, including the US environmental protection site. And what you're seeing here, it's application to the Hong Kong tourism webpage, which I thought is quite appropriate for this audience. So on the top left, we use Delicious, which is a social bookmarking software site in the cloud, and gather thousands of tags, and we analyze those tags. And on the bottom left is, you see it, and it's real, and it's the sitemap of the Hong Kong Tourism Board web pages, depicting, major tourist attractions in Hong Kong. On the right, you can see that the merged sitemap, which is based on the original sitemap structure with new tags that is being analyzed, filtered, refurbished, and add back to the sitemap. So you can see that, for example, traditionally, if you want to find out where can I see pandas in Hong Kong, right? You search Google, and you may come to this site, and then you look at different pages, look at the different websites, and see which one mentions panda, right? Or you can rely on Google keyword search. But in this case, we give you a third way of navigation, because pandas is commonly a word that people use to refer to Ocean Park in Hong Kong. So you can see that panda is a word, it's a label that's being added to the sitemap, right? So in this case, I thought it's quite useful, so that people are being offered an additional dimension for navigation, which frees them up from reading and searching, and is very much based on citizens' contributions. This goes back to, to my response or my suggestion to one of Professor Totteman's opening points yesterday. He said that, where does the library sit? The library provides so much classification material, using a jewelry classification and other things, and many people come and navigate for these things. So perhaps you can also erect a similar type of system to collect massive amounts of tags for generating an enhanced classification system. So allow me to finish in about 5 minutes and finish up with learning. I'd like to take on two aspects about how to use the cloud for learning. If what we're hearing from other speakers are correct, allow me to summarize it. I believe there are major forces impacting the learning landscape. Firstly, the onset of the knowledge work, which I've mentioned before. It's a proliferation of social media and the speed in which these things are being gathered. Of course, mobile devices, mobile technologies continue to revolutionize, the way that we learn. There's a skill gap out there, which many universities may not realize or may not be preaching at the moment, but that's outside the scope of my talk. What I really want to focus on is, P-based personal learning environments for individual knowledge workers, as well as this concept called MOOCs, massive open online courses. Let's start with the MOOC first, Introduction to AI. I think many here, if not all, teach this course. I teach certain parts of this course at PolyU as well, and some years ago I realized that, hey, there's a MOOC out there, so I directed my students to look at this rather than, going through all the major concepts. But during the class, I will explore in-depth concepts with them. But it all started in 2011 when two Stanford professors realized that every year we teach this course to 500 and 600 students. Why don't we just record the video and put it online so that more people can benefit? The students who come, they will come. For the students who don't come, at least they've got a digital copy that we can replay. And to their surprise, that 500 or 600 students a year turn out to be 160,000 students across nearly 200 countries. Well, once again, you need to have a cloud in order to support that. But MOOCs is a lot more than, running e-learning on the cloud, a lot more, right? Now, I'm not trying to get into a debate into MOOC here. Some people, shut off, once you talk about MOOCs. They don't trust about the authenticity nor the quality of the courses. And some people also discount the fact that, look, he hasn't gone through a strict academic accreditation. So many of these courses may not be, trustworthy enough or authentic enough to be recognized, to be converted to a degree. And that sort of thing is certainly true. All universities are still struggling, I think that's the right word, to look for a viable business model for MOOC. But it defies many of the things that we know. You don't screen the qualifications of the applicants, and most of the assessments are online. In fact, all of them are online. Most of them are multiple choice only, and you don't have any face-to-face contact with any of the learners at all. However, that said, many MOOC providers cropped up, mostly American, but several European and also one or two Australian as well. Why universities are supporting MOOCs? Well, I think the writing's on the wall. Many of them want to raise the profile. Many of them want to, extend the reach of the education to a much bigger group of people. But I think that there are more innovative uses of MOOCs available. For example, me and some of my colleagues in PolyU and many other universities as well are using MOOCs, as I said, to enact the flipped classroom. So instead of teaching a course or teaching a particular topic and using the precious 2 or 3 hours, we ask the student to replay a recorded lecture first. And then when we go into the lecture, that precious 2 or 3 hours, we engage in deep, topic discussions. And that's exactly what we're doing on Saturday when I return to Hong Kong. Our university is also leveraging on MOOCs to embark and start on blended learning, because it sounds too hard, if you just try to push e-learning and blended learning to many staff. But MOOCs seem to be, a logical sequence, or at least an intermediate point for them to explore. To crowdsource quality content, not only from teachers, but also from learners. 2 examples there. The first one, I suppose, German university is very proud. German's MOOC provider, Iversity, several years ago, put up a fund for, I think it's 10,000 euros, okay? To invite the world's professors, anybody, to suggest a topic that you want to put on Iversity. Iversity will pay for the hosting and the running of the subject. So, and they ask you to provide a 10 minutes, it's a sample of the course that you would like to provide. And the winner is being given, a certain period of time and also 10,000 euro to develop that course and offer in Iversity. Now that has a disruptive input to university. Right? Traditionally, university would think that we ask our professors to develop a course. If we don't have that expertise, we either learn it or hire another person to do it. But in this case, you can go to the world and ask people, who excel in certain areas, compete, submit a proposal on certain course, and you pick the best brain and develop a course and host it on your platform. The same goes with crowdsourcing the content from the learners. In one of the universities in Hong Kong, I think it's University of Hong Kong, actually, they have a MOOC course on Chinese historical buildings or nice architectures of Asian buildings. So in one of the assignments, the professors said that students around the world go and take pictures of ancient Oriental architectures in your own city. All right, and submit that as your assignment. And he promised you'll pick the best and embed it into the second, delivery of the learning content. So using this, you reach out to an audience and draw on their input to better your content in the subsequent deliveries. So more and more of these wonderful stories are coming out as well. And in our university, we are rapidly preparing for our MOOC and preparing for these things to become innovative. Well, we are in alliance with the edX platform, and I'd like to especially mention that we are preparing our first MOOC, Knowledge Revolution, from KM, Big Data to Cloud Services, and we aim to launch it in August of this year. A very special thank you and pay our respect to Professor Totterman and his team that helped us a big hand on the sections on Science 2.0, open link data, and social media. And Prof. Totterman and his team has been working very hard with our team to coordinate content, recording videos, and so forth. And separate, and in addition to what I've just said, our team is also on the research level working on the personalization engine to identify the learning analytics that is so needed to help with the individualization of the pedagogy and learning content that we can deliver to students. Finally, to allow me to talk a little bit about micro-learning inside the cloud. And everyone, I think, agrees today, learning is not just one big hall, although I'm doing that for the last 25 minutes, which is no good. Right? We're supposed to be talking to each other and learning with each other. I observe my students often, form the ad hoc learning groups, and they learn from each other as well as from other people as well. So some years ago, I did some research and developed a platform, personal learning environment and network. I call it PLEN. So basically, it's a platform that operates on Google tools. So anyone who operates using a standard set of Google tools, in fact, all we need is Google Plus Community, and the Google address book, all right, and the Gmail address. So once you have those 4 things, I'll give you the guidelines to all my students to set up a personal learning environment. In that environment, we also have automatic RSS feeds of quality content coming in from various topics. I select them, but later on, students also contribute. So other than that, they can do whatever they like. They can add whatever learning components into their own learning environment. So some students use Gmail, they use Flickr, they use Wikipedia, and they can use Symbaloo, and among other things as well. And through this environment, I brought together teachers, students, graduates, which is not easy for a traditional university environment, and other practitioners. And today, after operating this environment to more than 2,000 students at PolyU, I've extended the platform to universities in Thailand, as well as tried fusing classes from the different levels and also from different universities into one to stimulate, to further learning and knowledge fertilization. So for those of you who want to know more about this kind of platform, I have a brochure to talk about that. And it's in the public domain, so there's nothing secret about it. And it's been a very productive and rewarding platform for all of us. So wonderful opportunity for me, and I'd like to finish there and thank you and put it back to Professor Wittberger. Thank you.
Thank you, Eric. Questions? 1 or 2 questions, if possible. A lot of information. I have one. Regarding the social bookmarking things you mentioned, did you make any research whether the bookmarks you got from people from the social bookmarking areas are different to them? Are they on another type of taxonomy? Are they broader? Are they more specific? Or is there any?
Okay, based on the text that we have collected, which is in the thousands mark, we have derived several generalizations and learnings, right? The people who started using the tags, sometimes they may use the wrong tag, and other people don't bother correcting them. So, for example, when you talk about Soho, maybe you should use night live. Well, I find that people use night light, and all other people continue to just +1 on that tag. So the second thing is, again, referring to Hong Kong, some people type Hong space Kong, some people type HK, some people type Hong K, and many others. So we do have to use a lot of ad hoc rule of thumb and linguistic technologies to clean all that up and consolidate it. Right, so you are right. Tags have no hierarchy, although there has been some research done to try to rediscover some dependence and network relationships among the tags. But so far, I don't think that that has developed into a full-scale research momentum.